Hi, everyone. We'll get started in about 4 minutes. And Cloud Classroom sent you guys an email saying that the class is now an hour and a half instead of 2 hours. So we'll end at 7:30 from now.
Okay. Are we gonna do Quizlet today?
Yeah, at the end of class.
Yes.
Well, actually, maybe not because I'm not sure if we can get through the lesson today, but we'll see. Okay, it's 6 o'clock and we'll get started. Okay, so today's lesson is going to be about number theory. So it's all about finding patterns in numbers. So number theory is a study of integers. So you guys will look for patterns that will allow you guys to solve problems with ease. And it allows you to become more familiar with these numbers. So first we'll talk about multiples. So a number A is a multiple of another number B if A equals B times N. And N is an integer. So for example, 3 is a multiple of 4, and 4 is also, no, 3 is a multiple of 12, and 4 is also a multiple of 12. Negative 3 is a multiple of 12. 12 is a multiple of 3. 4 is negative 12 is a multiple of 4. My bad. Flip that. So 12 is a multiple of 4 and 3. 0 is a multiple of 4, 4 is a multiple of 4, because if you divide 4, these numbers by 4, you guys will all get an integer. And here's an example of something that is not a multiple of 4. So you cannot divide 7 by 4 and get an integer. So for example, if both 147 and 357 are multiples of 7, and if you add those together, the answer will be a multiple of 7. So anytime you add two numbers and they're both a multiple of one number, such as 7, the sum will be a multiple of 7. So try this with any number, and it will work. So we can use a distributive property to rewrite as 7 times 21 plus 51, and this becomes 7 times 72. And here's an example of something that will not be a multiple of 7. So 14 is a multiple of 7, but 23 is not a multiple of 7. So if you add those two numbers together, you will not get a number that is a multiple of 7. And this pretty much says the same thing. So if you guys look at the sequence, 84, 77, 70, all of these numbers are multiples of 7. If you add or subtract any of these numbers together, the answer will be a multiple of 7. So this all says the same rule. And once again, if you guys look at the bottom here, 49 minus 5 equals 44. 5 is not a multiple of 7. So the answer will not be a multiple of 7. So to sum it up, both numbers have to be a multiple of the same number for the answer to be a multiple of that number. So is every multiple of 15 also a multiple of 3? The answer is yes, because 15 is a multiple. 15 equals 5 times 3. So if you multiply 15 by any number, that number will can also be divided by 3. So 15 times 2 equals 30. 15 times 5 equals 75. Both of these numbers can be divided by 3. And then we can generalize this in the bottom. So if A is a multiple of B, so and then every multiple of A is also a multiple of B. And here are some challenge problems. So what number between 100 and 200, not including 100 and 200, is a perfect square and a multiple of 7? What is the greatest three-digit number that is a multiple of 17? And how many integers between 13 and 3,428 are multiples of 11? So I'll give you guys a few minutes to solve these, and then feel free to ask me any questions in the chat. Okay, I'll give you guys about 2 more minutes.
Okay.
Okay, so I'll give you guys the answers right now. So for the first one, the answer is 196. So 100, first of all, 196 is is within the range of 100 to 200. And 196 is a perfect square. So 196 is 14 times 14. And 14 is a multiple of 7. So that means 196 is a multiple of 7. You guys kind of needed to do some guesswork on where to start for squares, perfect squares. But if you guys already knew up to like 14, then it should be pretty easy. All right, second one, what is the greatest three-digit number that is a multiple of 17? The answer is 986. So if you divide 986 by 17, you guys get 58, which is an integer. So that means it is divisible by 17. So one way you guys could do this is divide 1000 by 17. And you guys you guys should have gotten a remainder. And then once you guys saw that remainder, you guys should have gotten a remainder of 14. So then once you guys get the remainder, you guys can subtract 1000 by 1000 minus 14, and then you guys should get 986. And then the last one, how many integers between 13 and 3428 are multiples of 11? And the answer is 310. So the way to do this is find out what the smallest multiple of 11 is within this range and the greatest. So the smallest multiple of 11 within this range is 22. And the greatest is, I believe, 311. Yes, 311. So that is your limit. So 311 to and 22. So if you guys count up all the numbers within that range, you guys should get 310 numbers. So the answer is 310. Okay. So now we're going to talk about a bunch of divisibility tests. So and these numbers will go from 2 to 11, I believe. So these are some easy tests that you guys can do to numbers to see if a number is divisible by a number. So 12 is divisible by 4 because it gives an integer. And 12 is also a multiple. And this means 12 is a multiple of 4. So when we say a number is divisible by something, that means it is a multiple of something. So first we'll start with the divisibility test of 10. So this is pretty easy to get. So 10, 20, 30, 500, 600, 700, all these numbers are divisible by 10. That is because they end with a 0. So any number that is a multiple of 10, it will end with a 0. So 5, 25, 36, all these numbers, they don't end with a 0. So they are not divisible by 10. And then this is because if you multiply each of these numbers by 10, all of those, the product will end with a 0. So 5 times 10 is 50, 250, 360, 990, 1,310. So that's how you know if something's divisible by 10. And 5 is also pretty easy. So for example, 10 equals 5 times 2. So every multiple of 10 is divisible by 5. We know that because of this. And we look at this pattern, 5, 10, 15, 20, 25. Well, all the numbers end with a 5 or a 0. So all multiples of 5 will end with a 5 or 0, no exceptions. Divisibility test 2. 2, 4, 6, 8, 10, 12. All of these numbers are divisible by 2. And that means every even number is divisible by 2. And also no odd numbers are divisible by 2. 4. So every multiple. So this is a trick to use for 4. So what we do is we look at the last 2 digits of a number and see if that's divisible by 4. And if that number is divisible by 4, that means the whole number is divisible by 4. So for example, we look at 312. So that is, we take the last 2 digits, so that is 12, and 12 is divisible by 4. So that means 312 is divisible by 4. And try these with 512 and 2512, and then they will also work. They are also divisible by 12. This is because we can split up these numbers into, for example, for 312, 300 plus 12. Well, we know every multiple of 100 is a multiple of 4, because 100 equals 25 times 4. So this number, the first number, will always be a multiple of 4. So all we gotta do is focus on the last 2 digits. Okay, so we're not adding the last 2 digits. We're just taking that apart from the number. So for example, 312, we're not adding 1 and 2. We're just taking it apart. So 12, the 312, the last 2 digits are 12. So we don't add the last 2 digits. Okay, 8. So very similar to 4, except we split it up with the thousands place. So first off, 1,000 is divisible by 8. So that means every multiple of 1,000 is a multiple of 8. So when we do this to a number, split it up again. So for example, 45,672, that will produce 45,000 plus 672. So every multiple of 1,000 is a multiple of 8. So we know this part is a multiple of 8. So all we gotta do is look at the last 3 digits of a number and see if that's divisible by 8. So remember, for the 4 divisibility test, we look at the last 2 digits, and for 8, we look at the last 3 digits. And then 672 is a multiple of 8. So this number is a multiple of 8.
I have a question.
Yeah.
So for 16, is it like if the 4 for 16, is it like the last 4 digits are divisible by 16?
I believe so. If you go by the pattern, then yes. Yeah. Okay, so divisibility test 9 and 3. So these are pretty much the same thing. So all you gotta do is add up all of the digits in a number. So this time you do add up the digits. And then if that number is divisible by 3 or 9, then the whole number, then that number is divisible by 9. So for example, 765. This is a pretty big number, and we want to know if it's divisible by 9. So all we got to do is add up all these digits. So 7 plus 6 plus 5 and that equals 18. And 18 is divisible by 9. So that means 765 is divisible by 9. And here's a little proof of why this works. So we can split up 765 into 7 times 100 plus 6 times 10 plus 5. And then we split that up again into, we split up the 100 into 99 plus 1 and the 10 into 9 plus 1. And then when we use this, we multiply it out, we get 7 times 99 plus 7 plus 6 times 9 plus 6 plus 5. Well, we know this part, the blue part, is divisible by 9 because it has a 9 and a 99. So all we gotta do is focus on the red part to see. Someone raise their hand.
Yeah. Why is there a times 2 at the end of 7 plus 6 plus 5 equals 18?
Yeah, that's just to prove that 18 is divisible by 9.
Oh, I see.
Yeah. Okay. So divisibility test 6. So there isn't really a rule for this one, but you can combine the previous 2 rules for this one. So if a number is divisible by 2 and 3, then the number is divisible by 6. So for the 2 divisibility test, if it's an even number, it's divisible by 2. And for 3, it's the same rule as 9. So for 3, if we add up all the digits and if that number is divisible by 3, then the number is divisible by 3. And this is because 6 is a multiple of both 2 and 3. So every multiple of 6 has to be a multiple of 2 and 3. So for example, 252. So we try this out for 3. So 2 plus 5 plus 2 equals 9. But remember, 9 is also a multiple of 3. So equals 9. So 9 divided by 3 is 3. So this number works for the 3 divisibility test. And 252 is an even number. So this number is divisible by 6. Okay, 7. So this rule is a little bit complicated. So take the last digit of a number and double it. Then subtract this number from the remaining digits. If the difference is divisible by 7, then the number is divisible by 7. So for example, 2023. So we take the last digit 3 and then we double it. So that equals 6. And we have the remaining digits of 202. And then 202 minus 6 equals 196. And that is divisible by 7. But if you don't know if 196 is divisible by 7, you can do it again. So we take the last digit and we double it. So 6 times 2 equals 12. And then subtract that from the remaining digits. So 19 minus 12 equals 7. And we know for sure that 7 is divisible by 7. So that means this number, 2023, is divisible by 7. And this proof is very similar to the proof I showed you guys for 9 and 3. So we would split up the number like 2 times 1,000, 2 times 20. And we can prove that way that this divisibility test works. And then 11. So take the alternating sum of the digits in a number from left to right. If the sum is divisible by 11, then the number is divisible by 11. So this is what I'm talking about. So let's take, for example, 2,728. So 2 minus 7 plus 2 minus 8, that equals negative 11. And negative 11 divided by 11 is negative 1, which is an integer. So that means this number, 2,728, is divisible by 11. So it's plus minus, and that is the number you will test out. Okay, and here are some challenge problems for these divisibility tests. So there are 5 of them, and I will give you guys about 10 minutes to do them. If you guys need more time, then I'll give you guys more time. So right now, please get started. Guys, so these numbers are split up by the semicolon. So the comma here, that's part of the number. So these are not separate numbers. The separate numbers are the ones divided by the semicolon. So 1, 2, 3, 4. So guys, ignore the commas. That's part of the number. Okay, I'll give you guys about 2 more minutes. Okay, I will go over the answers right now. So which of the following numbers are divisible by 3? So just use the 3 divisibility test and see if these numbers work. And if you guys do that, the only numbers that are divisible by 3 here are 60,231,060 and 9,671,118. So these are the only 2 numbers. So the last 2 are the answer. And I know the comma kind of messed you guys up a little bit, but the comma is part of the number. So guys, please ignore the commas. So which of the following numbers are divisible by 4? So we use the 4 divisibility test. So we look at the last 2 digits and see if that's divisible by 4. So 24, that's divisible by 4. So this one works. 35, that's not. 60 is divisible by 4. That will give you 15 if you divide it by 4. And 18 is not divisible by 4. So the answer to this one is the first number and the third number. Which of the following numbers are not divisible by 7? So you guys don't really need the 7 divisibility rule right here. You guys just need to see, you guys can split up the number and see if that's divisible by 7. So for example, 7,014,000, you guys can split it up into 7,014,000. And both those numbers are divisible by 7. So this one works. Same thing with 14,035. You guys can split that up. The third number, you guys can split that up too. Split it up with the 7s together, and the 28. Those numbers are also multiples of 7. And if we do that, we see the only number that's not divisible by 7 is the fourth number. So when we split this number up right here, and we take the last 2 digits, which is 34, the remainder, that number is not divisible by 7. 35 is divisible by 7, but 34 is not. But you guys could use the 7 divisibility test for this one. But some of these numbers, you guys can just split it up and see if that works. So how many numbers from 1 to 400 have a 2 in the ones place and are divisible by 4? So to solve this one, you guys first need to find the numbers that have a 2 in the ones place and see which ones are divisible by 4. And the easy way to do, one way to do this is to split it up into sections, into quarters. So first look at 1 to 100 and see if there's a pattern there. So when we do that, we see that from 1 to 100, we have 5 numbers that have a 2 in the ones place and are divisible by 4. So 12, 32, 52, 72, and 92, those numbers are all divisible by 4. And when we do that, we see that we realize there's 5 numbers in each quarter. So from 101 to 200, 201 to 300, 301 to 400, there's always 5 numbers in those quarters. So when we add it up, we get 20 numbers in total. So the answer to this one is 20. The last one. Both ABC and 3D8 are 3-digit numbers such that ABC minus 3D8 equals 269. So if 3D8 is divisible by 9, then what number does ABC represent? So we have a clue here. So 3D8 is divisible by 9. That means when we add up all the digits to 3D8, that number is divisible by 9. Well, 3 plus 8 is 11. And we know 18 is divisible by 9. So we do 18 minus 11. So that means D here represents 7. So 378. Well, we know this number, so all we gotta do is find ABC. So we just add 378 to 269. And that number is 647. So the answer to the last one is 647. So once again, algebra, we represent numbers with variables or letters. So these letters represent numbers. Okay, now we talk about prime numbers. So prime number is a positive integer that is only divisible by 2 positive integers, 1 and itself. So for example, 3 can only be divided by 3 and itself. It cannot be divided by 2. And 5 is another prime number. 5 can only be divided by 5 and 1. A composite number is a positive integer that is divisible by more than 2 positive integers. So the smallest composite number is 4. So 4 can be divided by 4 and 1, but it can be also divided by 2. And 1 is neither prime nor composite. So guys, remember that. When I ask you guys for prime numbers, ignore 1. So that means the smallest prime number is 2. And in fact, 2 is the only prime number that is even, because every other even number is divisible by 2. So they're all composite. So just remember, prime numbers only divisible by itself and 1. And here's a fun fact. The largest known prime number so far is 2 to the 82,589,933rd power minus 1. And this number has 24,862,048 digits. And we do not use humans to find these. We use computers. There's actually a very big search going on right now to find the biggest prime number that we can find. There are actually an infinite number of prime numbers, but there's a big search going on to find larger ones, even larger ones than this. So you guys can do that if you guys want. So testing for prime numbers. So is 113 prime? So we test if 113 is divisible by any prime numbers. So we don't test composite numbers because every composite number is a multiple of a prime. So we don't need to test composite numbers. We only need to test prime numbers. So what we do here is we square a prime number, such as 11, and see if the square of that number, 121, is larger than the number we are testing, 113. And if it is, which in this case it is, then that means every prime number, that means we only need to test every prime number that is less than 11. So to sum it up, we take a prime number, we square it. If that answer is greater than the number we are testing, then we test every prime number that is less than the original prime number, which is 11. So we test 2, 3, 5, and 7. And once we do that, we see that 113 is not divisible by any of those prime numbers. So 113 is prime. And the reason we square it is because, well, when we go in reverse order, So we test all the smaller prime numbers up to 11. We see that no number up to 11 is divisible. 113 is not divisible by any number up to 11. So we ask ourselves, are there any prime numbers bigger than 11 that we can test? But we don't need to, because 11 times 11 is 121, and that's already bigger than 113. Because 11 times 11, that's the smallest possible number you can get if you multiply by any numbers greater than 10. So if you multiply by 11 times 13, it's still going to be greater than 113. So it's not going to work. And here's a test that you guys can do to find prime numbers. It's called a sieve of Eratosthenes. I'll probably butcher that. So here's what you guys do. So first, we circle the smallest prime number, which is 2. And then we cross out all of the multiples of 2. So 4, 6, 8, 10, that means all of the even numbers here, we cross out. And then we repeat this process. So we look at 3, and we cross out any multiples of 3. And then some numbers are already crossed out because some numbers are multiples of 2 already, such as 6. 6 is already a multiple of 2, but it is also a multiple of 3. So we cross out 9, 15, 21, and then we repeat this process. And once we do that, we can single out all the prime numbers. So 2, 3, 5, 7, 11, all the way up to 97. So within the first 100 digits, these are all the prime numbers. And once again, 1 is not considered prime nor composite. It's in a category by itself. And we can see here that 2 is the only prime number that is even. So here's this is a pretty neat way to find prime numbers. And you guys can do this with however many numbers you want. You guys can do this with 1 million numbers, 10 million numbers. It's obviously going to take longer, but it's a good way to do it. So here are some challenge problems. You guys can cross out the first one. How many even prime numbers are there? The answer is 1. 2 is the only even prime number. So I'll give you guys around 10 minutes again to do these. So 6:57, and please get started.
Can people please stop putting random stars on there? It's starting to get annoying.
Yeah, can you guys please not draw anything on there?
Excuse me.
Yeah.
What does the last question mean? I don't really understand like the wording.
Okay, so how many pairs of primes are there? So if you add up two prime numbers, how many pairs are there that the sum is 40? It's like, for example, 1 plus 39, that equals 40, but that's not the answer because 1 is not a prime. So try to look for how many pairs there are.
Okay, thanks.
Yeah. Okay, I'll give you guys about 1 more minute. Okay, I will go over the answers right now. So let's start with the second one. So what is the sum of all prime numbers between 80 and 90? So we gotta find the prime numbers. So, and when I say between 80 and 90, we do not include 80 and 90, although these are not prime, so it doesn't matter. So 81, that's divisible by 9. That's actually the square of 9, so that's out. And we get rid of all the even numbers. So 82, 84, 86, 88, those are all out. And the first prime number we come across is 83. So that is one prime number. 85 is divisible by 5. So that is not, that's composite, that's not prime. And 87 is actually also divisible by 3. One way to know, so 81 is divisible by 3. And if we add 6 to that, we get 87. And 6 is also divisible by 3. So that means 87 is divisible by 3. So that leaves 89. And we do all the tests to it, and we see that 89 is also prime. So the answer is 89 plus 83, and that will give you 172. So a lot of tests going on. So, number 3, find every number between 70 and 80 that is not prime, so composite, and is not a multiple of 2, 3, or 5. So that means we get rid of all the numbers that are multiples of 2, 3, and 5. So all the even numbers, and all the prime numbers. So all the prime numbers in this range are 71, 73, and 79. So those numbers are all prime. And all the even numbers are out because they are multiples of 2. So, and 75 is a multiple of 5. So that leaves only one number, I believe, which is 77. So 77 is not prime. That is divisible by 7 and 11. And it is not a multiple of 2, 3, or 5. So the answer is 77. What is the largest prime number p such that 8 times p is less than 1000? So we can divide 1000 by 8, and we will see that the answer is 125. So that means all the possible answer will be less than 125. So all we got to do is test the numbers that are less than 125. But we can get rid of all the even numbers because they're all multiples of 2. So that's out. So then we test 123, 121, and so on. So when we do these tests, we find that the answer is actually 113. 121 is the square of 11. So that's out, that's composite. 119 is divisible by 7. And 117 is divisible by 3. 115 is divisible by 5. And 123 is divisible by 3. No, that is not. What number is that divisible by? 3. Yeah, 123 is divisible by 3. Sorry. So that leaves us with the largest number, which is 113. That number is prime. That is not divisible by anything else other than 113 and 1. So, and the last one, how many pairs of primes are there such that the sum of the pair is 40? So for example, maybe 1 plus 39, that is a pair and that equals 40. But 1 is not prime and 39 is also not prime. So that's out. So for this one, well, we can add up all the possible, we can find all the possible pairs that add up to 40. But we can skip all the even numbers, like 2 and 38, 4 and 36. Those are all going to be, those all have even numbers. So you guys can get rid of those. That's basically half. So just add up all the odd numbers and see which ones work. And once we do that, we find that the only pairs that work are 3 plus 37, 11 plus 29, and 17 plus 23. So that leaves us with only 3 pairs. So the answer is 3. Okay, so now we go to prime factorization. So we can express a number in terms of its prime factors. So for example, 12, we can express this as 2 times 2 times 3. Those are all the factors of 12. Those are factors of 12. They're all prime. And we can write this using exponents. So 12 equals 2 to the second power because there are 2 2s, and 3 to the first power because there's only 1 3. And I've actually never heard of this before, but the book calls it the fundamental theorem of arithmetic. Every positive integer has a unique prime factorization. So if you multiply, if you find the prime factorization of all numbers, they're all going to be different. And here at the bottom are some examples of factor trees. So 12, that can be split into 2 and 6, but 2 is prime, so we circle that. And then we go to 6. Then 6 is divisible by 2 and 3, and we circle those two because those are both prime. So that is our prime factorization of 12. So right away, again, here are some challenge problems. I will give you guys like 5 minutes. Just do as much as you can. It doesn't matter if you guys finish it or not. I shouldn't have given you guys problems right away, but it doesn't matter. So find the prime factorization of each of the following numbers. Okay, about 1 more minute. Yeah, okay. I'll just go over the answers right now. All right, so 16, that's 2 to the 4th. 30, 2 times 3 times 5, 36. 2 squared times 3 squared, 60. 2 squared times 3 times 5, 144. 2 to the 4th times 3 to the 2nd, 252. 2 to the 2nd times 3 to the 2nd times 7. And the last one, 288. 2 to the 5th times 3 to the 2nd. So I won't explain those. You guys know, go use the factor tree and just keep breaking it down more and more. So if you guys don't know where to start, well, if it's an even number, you know it's divisible by 2. So you guys can start from there. And then if it's even again, then you guys can break that down again. Remember, don't break down any prime numbers. So if it's 2, that is prime, so circle it. So you don't break that down again. Right, so an infinite number of primes. So this is why. So a number n is a product of the 3 smallest primes, 2 times 3 times 5. That number is 60. The prime factorization of n plus 1 must include a prime that is not. What happened here? All right, can you guys please stop doing that? I saw a big square. So the prime factorization of n plus 1, so 30 plus 1 must include a prime that is not among the 3 smallest prime numbers. And that's true. So because 31, that number is prime, and so we get a new prime number. So this proves that there are an infinite number of prime numbers. So we can do this for even bigger numbers, way bigger than 30, and this will remain true. I didn't realize I gave you guys so many challenge problems. So here are some again. So find the prime factorization of each of the following numbers: 243, 539, 5525, and 26136. And the last one includes a factorial. So if you guys might have seen this exclamation point in math. That doesn't mean you shout 40. That actually means you multiply all the numbers up to 40. So if it's 40 factorial, then it's 1 times 2 times 3 all the way to 40. So when you guys write math problems, try not to use exclamation points because we actually use those in math. So in the prime factorization of 40 factorial, what is the power of 5? So is it 5 to the 1st, 5 to the 2nd, 5 to the 100? It's not. Yeah, I don't think we're gonna finish today. this unit. So I guess no Quizlet, I guess. Sorry for you guys that want to play Quizlet. Yeah, we can try Kahoot next time, actually. We'll see if we have enough time to play Quizlet. So if we somehow get through it, then yeah, we'll play. One more minute, guys. And just to let you guys know, we end at 7:30 from now on. Cloud Classroom should have sent you guys an email saying we end at 7:30. So every class is 90 minutes from now on. Okay, so I will go over the answers right now. So 243, the answer is 3 to the 5th. 539, the answer is 7 squared times 11. 5525, the answer is 5 squared times 13 times 17. And 26,136, that answer is 2 to the 3rd times 3 to the 3rd times 11 squared. And the last one. So the answer is 5 to the 9th. That is the power of 5. So the way you do this is you see you count how many numbers all the way up to 40 are multiples of 5. And once you do that, you see that there are 8 numbers all the way up to 40 that are a multiple of 5. So that means they all contain a 5 in their prime factorization. So that means there are 8. But hold on, 25. Yeah, 25 is 5 times 5. So it actually has 2. So that means we add 1. So it's 8 plus 1. And the answer is 5 to the 9th. So for the last one, you're just focusing on the prime factorizations for the numbers.
Excuse me, can you can you repeat the 26,136?
Yeah, the answer is 2 to the 3rd times 3 to the 3rd times 11 to the 2. Okay, we'll move on. All right, so LCM, least common multiple. So this is the smallest positive integer that is a multiple of both A and B. So for example, 12 is a multiple of 2 and 3, but that is not the least common multiple. The answer is 6. 6 is the least common multiple of 2 and 3. And we write that as LCM brackets 2 and 3. So LCM. So we look at the top here, so multiples of 18 and multiples of 24. So if we write out all the multiples of 18 and all the multiples of 24, we see that the LCM is 72. So 72 here and 72 here. But we also look at the common multiples greater than 72, and we see that those numbers are also multiples of the LCM. So what this means is every common multiple of 18 and 24 will be a multiple of the LCM. And this is true for any numbers. And we find the LCM by prime factorization. So say we want to find the LCM of 24 and 90. So we find the prime factorization of both numbers. So 2 to the third times 3, and 2 to the first times 3 to the second times 5 to the first. And what we do here is we circle or underline the greatest power of a number in both. So for example, both of these have 2 raised to a power, but in 24, the 2 power is greater, it's to the third. So we circle that one. They both have a 3, but in 90, the power of 3 is higher. It's 3 to the second, so we circle that one. And 90 also has a 5, but 24 does not have a 5, so we circle the 5 in 90. And we multiply those numbers. So 2 to the third times 3 to the second times 5, that equals 360, and that is the LCM of 24 and 90. So that is how you find the LCM. So remember, do the prime factorization, which you guys already know how to do, and find the biggest power between those two numbers, and then multiply all those. And here's an interesting fact, I guess. So say we want to find the LCM of 500 and 300. So 500 and 300, that equals, the LCM of that is 1500. And say we want to find the LCM of 2 times 500, 1000, and 600, which is 2 times 300. And we see that the LCM is 2 times the LCM before. So LCM of 2 times 500 and 2 times 300, that is 3000, and 3000 is 2 times 1500. So if you look at the bottom here, this is a rule for LCMs. So LCM, an integer times a and the same integer times b, we can take this integer out, and it will be the integer times the LCM of a and b. So that's an interesting pattern we see here for LCMs. And once again, we have challenge problems. So we have 6 pairs of numbers, and I want you guys to find me the LCM of each of those. And I think we'll stop here for today. So I'll give you guys all the way up until 7:28, so 5 minutes. And after that, I'll go through the problem. I'll go over the answers, and it will end at 7:30. And then next lesson, we'll start from where we stopped. So next lesson, we'll start with GCFs, which is greatest common factor.
And after, can we play Kahoot?
Yeah, we'll play Kahoot for a little bit after that. So we'll play Kahoot anytime we finish a unit. And I will also send you guys the PowerPoint after today. So you guys can go over the rest of the PowerPoint that I didn't cover today. So you guys can get a head start on that. Okay, I'll go over the answers right now. So LCM 14 and 21. The answer is 42. Yeah, 42. LCM 24 and 32, 96. 27 and 63. The answer is 189. 54 and 60. 540. LCM 72 and 108. That is 216. And LCM 5096 and 117. That is 45,864. So pretty big number. So for all of these, just find the prime factorization for both numbers and then multiply the prime factors with the greatest power. For 54 and 60, the answer is 540. And the last one is 45,864. Okay. So we will stop here for today. So next time we will continue with GCF, which is greatest common factor. And after we finish this unit next lesson, we will play Kahoot or Quizlet Live. And yes, you guys can leave now. So thank you guys again for joining in. And I'll see you guys next time.
Okay, bye.
Bye.
Bye. Thank you.
No problem.
Thank you. Bye.
Bye.